Okay, in this session we're going to have a look at Unit 4, Chapter 4, Trigonometry in a Unit Circle, Trig Ratios Part 3, looking specifically at determining trigonometric ratios given a point on a circle. Okay, as we said, we're going to focus on relating the trigonometric ratios to the coordinates of points on the unit circle. We'll also have a look, by the way, at points not on the unit circle as well. Okay, primary trig ratios. Remember that the primary trig ratios are sine, cosine, and tan. You need to know now that sine is equal to the opposite over the hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Cosecant, which is the reciprocal of sine, of course, is hypotenuse over opposite. Secant is 1 over cosine, which is hypotenuse over adjacent. And cotan, which is the reciprocal of tan, is adjacent over opposite. So we'll look at an example. Example 1. We're going to be determining the trig ratios for angles in the unit circle first. Let's consider the point A, -3/5 and -4/5. So there's the coordinates of your point right here. It's in the third quadrant. It's on the unit circle. It lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. So again, notice it does say that it's on the unit circle. That means that the radius of this circle, of course, is 1. It says draw a diagram to model the situation. You see I've already done a part for you. I've drawn the diagram. You're asked to also determine the values of the 6 trig ratios for theta. Express answers in lowest terms. So we're looking for all 6 trig ratios here. We know that because the point is located on the unit circle, that any point on the unit circle can be represented as cosine theta, comma, sine theta. So it's pretty easy to identify what cosine theta is. Cosine theta is -3/5. And of course, sine theta is equal to -4/5. If I'm looking to find the other trig ratios, of course I need to use sine and cosine to help me do that. For example, tan of theta is equal to sine theta over cosine theta. And again, I want to reduce this. So sine over cosine is -4/5 divided by -3/5. When I reduce that, I will get a positive 4/3. Tan is a positive 4/3. -4/5 divided by a -3/5 will give me a positive 4/3. Of course, the cotan of the angle is the reciprocal of tan. So all I need to do is take the reciprocal of 4/3 and I get 3/4. The secant of the angle, secant theta, is the reciprocal of cosine. So if I look at cosine, I just need to take the reciprocal and I'll get -5/3. And finally, cosecant theta, which is the reciprocal of sine, all I need to do is look at sine, take the reciprocal, and I get -5/4. So the cosecant of theta is -5/4. Okay, there's the first example. Let's have a look at another example. Let's look at examples that involve calculating trig values for points not on the unit circle. Okay, here's the example. The point A, -4,3, lies on the terminal arm of an angle theta in standard position. What is the exact values of each trigonometric ratio for theta? Now, if you look at the diagram, you see that I have a point here, -4,3. Clearly, it's not on a unit circle. X is -4, y is 3. If I want to find the value of each trig function, or each trig ratio, sorry, all I need to do is this. The sine of the angle is equal to the opposite side over the hypotenuse in the triangle that you see over here. Now, the opposite side, what I look at is I look at the reference angle to do this. Here's the reference angle right here. The opposite side is 3. The hypotenuse, I don't know. I need to find that. So all I need to do is use the Pythagorean theorem to find the hypotenuse. So I got -4 squared plus 3 squared equals the hypotenuse squared. 16 plus 9 equals the hypotenuse squared. 25 equals the hypotenuse squared. So the hypotenuse will equal square root of 25, which of course is 5. And it's always positive. The hypotenuse will always be positive. So the sine of theta is equal to opposite over hypotenuse, which in this case, if you look at your reference angle, that's the angle we look at when doing this. If you look at this angle here, the opposite side is 3. The hypotenuse I just found was 5. So sine of the angle is 3 over 5. The cosine of the angle is the adjacent side over the hypotenuse. The adjacent side in this case is -4. The hypotenuse is 5. The tan of the angle is equal to opposite over adjacent. So the opposite side is 3. The adjacent side is -4. And of course, the other ones are just the reciprocal ratios. Cosecant theta is the reciprocal of sine. So all I need to do is take the reciprocal of 3 over 5 and I get 5 over 3. Secant theta is the reciprocal of cosine. So all I need to do is take the reciprocal of cosine, which is -4 over 5. The reciprocal of that will be a -5 over 4. And finally, the cotangent of theta, which is the reciprocal of tan, is going to be a -4 over 3. Again, if we look at tan being 3 over -4, -4 over 3 is the reciprocal. So there are the values of all 6 trig ratios: sine, cosine, tan, secant, cosecant, and cotan. But notice again that this point was not on the unit circle, and because it was not on the unit circle, I had to actually find the hypotenuse of that right triangle. Okay, example 3. Again, might be a good idea for you to try this one on your own before I do it. It's a multiple choice question. You're given the point 5, -3 are the coordinates on the terminal arm of an angle theta in standard position. What is the secant of that angle? Okay, so let's draw a diagram. Let's construct a point at 5, -3. Let me get rid of that there. So 5, -3 will be in the 4th quadrant. So here's my point, 5, -3. Construct my terminal arm right there. So there's the point on the terminal arm, 5, -3. Again, if I drop a perpendicular down to the x-axis, I know that this is 5 and this is -3. I'm looking for the secant of the angle. And again, I always look at the reference angle to do that. This is theta, but I look at theta r, the reference angle, in order to find the secant of theta. So, secant is equal to 1 over cosine. Cosine is adjacent over hypotenuse. So I need to find the hypotenuse. So let's do that. Again, we're going to do 5 squared plus a -3 squared equals the hypotenuse squared. 25 plus 9 equals the hypotenuse squared. 34 equals the hypotenuse squared. So the hypotenuse is equal to the square root of 34, and it's always positive. Okay, so secant again is 1 over cosine. Well, the cosine is equal to adjacent over hypotenuse. The adjacent side is 5, the hypotenuse is root 34. So secant being the reciprocal of that will be root 34 over 5. Root 34 over 5, and it's positive. There's your answer. Positive root 34 over 5. Let's have a look at one more example here. The point P of theta equals x comma -2 over 5 lies on the terminal arm of an angle theta in standard position and on the unit circle. That's important. This point is on the unit circle. You want to be looking for that. So let's construct the unit circle. And let's place our point on the unit circle. The point is at x and -2 over 5. It says, what is the exact value of secant theta if the point is in quadrant 4? So it's important that we know where the point is located. In this case, the point is located in quadrant 4. So let's place our point in quadrant 4. And we have the point x and -2 over 5. We know the y coordinate. We don't know the x coordinate. We're looking for the secant of the angle. To find the secant of the angle, we do need to know the x-coordinate, because secant is the reciprocal of cosine. So we need to be able to figure that out. Because it's a unit circle, the hypotenuse again in this triangle is 1. I can use the fact that the hypotenuse is 1 and the fact that I know the equation of this circle is x squared plus y squared equals 1 squared. X I don't know, y I do know. It's negative 2 over 5. So I'm going to do x squared plus a negative 2 over 5 squared equals 1. X squared plus 4 over 25 is equal to 1. X squared is equal to 1, subtract 4 over 25. X squared will equal 25 over 25, subtract 4 over 25. X squared equals 21 over 25. So what does x equal? X equals plus or minus the square root of 21 over 25, which I can simplify to the root of 21 over 5. So x is plus or minus the root of 21 over 5. But in this quadrant, we know that x is positive. So we're looking for the positive value of x in quadrant 4. So I have a positive value of x to be root 21 over 5 and negative 2 over 5 is our y-coordinate. Now, we're looking for the secant of the angle. The secant of the angle is equal to 1 over the cosine of the angle. The cosine of the angle is the x-coordinate. So I need to take the reciprocal of the x-coordinate, and it's going to be 5 over root 21. And you see that they actually left it like that, and 5 over root 21 is the answer. Typically, we had them on top of root 21 over root 21. But you see, if looking at the answers, we can see that that is the exact value that they wanted right there. Okay. So again, notice the point is on the unit circle. We need to use that information. Another example. Determine the exact value of the other 5 trigonometric ratios in the specified domain. This one's a little more challenging. We're looking for the exact value of the other 5 trig ratios. So, let's construct a diagram, first of all. Okay, cosecant is equal to the reciprocal of sine. Sine is opposite over hypotenuse, so this is going to be hypotenuse over opposite, isn't it? So cosecant is equal to hypotenuse over opposite. So I need to construct a diagram whereby the hypotenuse is 4 root 3 and the opposite side is 3. Now, before we do that, though, we need to consider the fact that cosecant is negative. And we need to think about our restricted domain here. If we consider our CAS rule, let's think about where cosecant is negative. Cosecant is negative in the same place that sine is negative. Sine is negative in this quadrant, and sine is negative in this quadrant. Now let's consider our restricted domain. The restricted domain is between negative pi and positive pi. That's really, if you think about that restricted domain, that's really 2 domains here. That restricted domain is the domain between 0 and pi and between negative pi and 0. So I'm just going to go up right here and highlight that restricted domain for you. Okay, so if we were to consider between negative pi and positive pi, that's really between 0 and pi, which is here, and between negative pi and 0, which is in here. Now, if we consider those 2 domains separately and consider where our terminal arms are located, the reality is that if we place terminal arms in the first diagram that I drew, there will be no values of theta that will exist here for those within that restricted domain. Between 0 and pi, your terminal errors don't exist within that restricted domain. However, it does exist in this restricted domain. So I do need to consider both quadrants here where cosecant is negative, because cosecant is negative in both of those quadrants. So we do need to consider both terminal arms. Let's do that. Now then, let's drop a perpendicular here. Again, we've said that the cosecant of the angle is equal to hypotenuse over opposite. The hypotenuse is 4 root 3. Hypotenuse is always positive. And the opposite side in this case is negative root 3. Same thing in the other quadrant. We have the hypotenuse is 4 root 3, and the opposite side is negative 3. In order to find the other trig ratios, we obviously need to find the other side in both triangles. We need to find this side, and we need to find this side. In order to do that, we're going to use the Pythagorean theorem again. Negative 3 squared plus x squared equals 4 root 3 squared. That's 9 plus x squared equals 16 times 3, which is 48. X squared will equal 48 subtract 9. X squared equals 39. So x equals plus or minus the root of 39. And there are two values for 39 here. We got a negative root 39 right here, and we got a positive root 39 right here. So we do need to consider both values. Now that we got our diagram labeled, I think we can start finding the other trig ratios here. We got cosecant, let's find the others. Now we need to consider in this restricted domain, is sine positive or negative and so on. So let's do that. The sine of theta is equal to, sine is equal to opposite over hypotenuse. Opposite over hypotenuse is simply going to be negative 3 over root 43. Negative 3 over the 4 root 3, sorry. 4 root 3. Opposite over hypotenuse. Opposite over hypotenuse. Again, you consider the reference angle in both of these triangles. Notice in this case, though, we get the same answer for both. The same answer for both is negative 3 over 4 root 3. Now, we never leave a radical in the denominator, so we do need to simplify this by multiplying by root 3 over root 3 to get negative 3 root 3 over 4 times 3, which is 12, which gives me a negative root 3 over 4. There's the value for the sine of the angle. Sine theta, only one answer. Cosine theta. Cosine theta is equal to the adjacent side over the hypotenuse. Now, think about cosine. Cosine is both positive and negative in these two quadrants. So we're going to be looking for two answers, a positive answer and a negative answer. And that makes sense because cosine is adjacent over hypotenuse and adjacent over hypotenuse. In this quadrant, we get a positive answer for cosine. In this quadrant, we get a negative answer for cosine. So it's going to be plus or minus, because again, cosine in these two quadrants are both positive and negative. And we get the adjacent side, which is root 39, over the hypotenuse, which is 4 root 3. We get rid of the radical in the denominator by multiplying by root 3 over root 3, which is going to give me the root of, let's see, 39 times 3 is 117, over 4 times 3, which is 12. The root of 117 divided by 12. Now, we need to break that down. The root of 17 is actually the root of 13 times the root of 9. Now the root of 9, of course, is 3, so I got 3 root 13 over 12, which will actually simplify to root 13 over 4. There's cosine. Now then, the tan of the angle is equal to the opposite side over the adjacent side. Now look at both triangles, opposite over adjacent. You're going to get two answers again because tan is both positive and negative in these two quadrants. So I should put my plus or minus in there, right? Because I started with plus or minus. Again, I got a plus or minus. Tan is opposite over adjacent. Look at your triangle, opposite over adjacent. That's a negative 3 over a negative root 39. And on the other side, it's a negative 3 over a positive root 39. That's why I put the plus or minus in there. Okay? So we got 3 over the root of 39. Don't leave a radical in the denominator. So we got 3 root 39 over 39. Reduce that, I get the root of 39 over 13. Don't forget, tan is both positive and negative in these two quadrants. Okay, we've got sine, cosine, and tan done. Cosecant is already given to us, so we don't need to worry about cosecant. We need to find the other two, though. And they are secant is the reciprocal of cosine. So if cosine is plus or minus 4 over root 13, secant is the reciprocal of that. And it's still going to be plus or minus 4 over root 13, multiplied by root 13 over root 13, and I get 4 root 13 over 13, again plus or minus. There is secant, again the reciprocal of cosine. And cotangent is the reciprocal of tan. The reciprocal of tan is going to be plus or minus 13 over root 39. Don't forget we got to multiply by root 39 over root 39 to get rid of the radical. And I get an answer of 13 root 39 over 39, which is actually root 39 over 3. 13 over 39 reduces to 1 over 3. And again, it's plus or minus. And there are all 6 trig ratios for that particular situation, whereby we got a diagram where the dangerous two terminal arms within that restricted domain. Okay, that was fairly lengthy, no question. Nice question, though. Okay, summary again, key ideas. You can determine trig ratios for any angle in standard position using the coordinates of a point where the terminal arm intersects the unit circle. And that's exactly what we did in that lesson. And that ends the lesson.